All right, this is Professor Pelton. This is part 1 of chapter 3, section 3. First, we're going to start off by doing the average rate of change. So we're going to do the rate of change for gasoline between these 2 years for these specific amounts, right? So the average rate of change. Okay. So the function values here are $4.66.8 minus, what is it, $2.45.7 and then you want to do 2022 minus the 2018. So what you want to do in these type of problems is current minus past. And what we mean by current is the most current. Otherwise, they give the reciprocal value, which is fine. Not the reciprocal, but the opposite value on the top and bottom, which will cancel it anyways, give the same answer. But okay, so 4.668 minus 2.457, that's going to give us what? 2.211. And then 2022 minus 2018 is a difference of 4 years. Okay, so if we divide those, 2.211 divided by 4, you're going to get 0.55275 over 1, right? Which is essentially $0.55275 per 1 year, right? Which is the one that's on the bottom. Okay, so a little more than 55 cents per year increase. All right, pause the video, try the student problem for yourself. Okay, so the student problem does the average rate of change for the bank accounts of the U.S. citizens. Okay, so the average rate of change equals, right, so the most current is 41,600 and the past is 42,580. Okay, so we have 2019 current minus 2016 past. So most current minus past. Okay, so it's going to give us a negative value on the top. So 41,600 minus 42,580 is negative 980. And on the bottom, 2019 from 2016 is a difference of 3 years. So it's not going to work out perfectly, but that's fine. So 980 divided by 3 is going to be negative 326.6 repeating over 1, or basically negative 326.6 repeating dollars per year that everybody's bank account is essentially going down on average. Okay. All right, so we can do the same thing with functions over intervals, whether it's a graph or the function is itself. So if we want to take this function over the interval of negative 2 to 4, even though the function's domain is actually forever in both directions, we can limit it to this specific domain. So the average rate of change, okay, will be f of 4 minus f of negative 2 over 4 minus negative 2. Okay, so the function value at 4 is 6 minus 2 times 4 to the third power minus the function value at negative 2 will be 6 minus 2 times negative 2 to the third power all over. So we have 6 minus negative 2, so that'd just be 6. Okay. All right, so the order of operations, so exponents first, so 4 to the third power is 64, correct? Times 2 is 128, so 6 minus 128, it'll be negative 122. And then 2 to the third power is 8 times 2 is 16, but this will be positive, right? Because the negatives will cancel out. So it'll be what, 22? Okay, so 22 and 22 gives me negative 144 over 6. So if I divide those, I get negative 24 is my average rate of change. Okay, pause the video. Try the student problem for yourself. Okay, student problem. So we get the average rate of change, the average rate of change. Okay, so we have f of 2 minus f of negative 1 over 2 minus negative 1. So the function value at 2 is 3 times 2 plus 6 over 2 squared minus 3 times negative 1 plus 6 over negative 1 squared, and then divided by the change in the interval, which is 2 minus negative 1. A little extra mark there for some reason. There we go. Okay, so order of operations, exponents first. So we really have here is 3 times 2 is 6 plus 6 over 4. Okay, and then minus, we have what? Negative 3, and that's going to be what's 6 plus 6, right? All over, let's see, 3 minus, that's a 3 there. Okay, so what we really have here is, we'll go all the way back over to here, 6 plus 3 halves minus, right? So we have 3 minus, that's 3 here, all over 3. Okay, so just multiply everything by 2 to make this easy. So times 2 over 2, right? So that'll give us a 12 plus 3 minus 6 over 6, right? So essentially we get 15 minus 6 is 9 over 6, right? So we have common factor of 3, so it's 3 halves is the average rate of change here. Okay. All right, let's go to the next page. Okay, so we can do the same thing with graphs. So the average rate of change from 0 to 3. So the average rate of change. So we want f of 3 minus f of 0 over 3 minus 0. Okay, let me get a better f of 0 of that. So f of 0. So on the bottom, I just get 3. All right, what's in the top? So the function value at 3, right? So that's x equals 3. So the function value is 1. Okay, and the function value at x equals 0 looks about to be 2. So I get negative 1 over 3. Okay, pause the video, try the student problem. So the student problem down here, I'm just going to do it up here. So the average rate of change equals f of 6 minus f of 3 over 6 minus 3. So I get a 3 on the bottom. So the function value at 6 gives us, what is this here, 5. So 5 minus, and we know this one's 1 from before, correct? So we just get 4 over 3 is our rate of change. Okay, so you can do that graphically. Okay, so we'll scroll down here. We can also do it algebraically for an unknown n value or beginning value, but this one's just specifically an n value. So we want the average rate of change, and we'll need to use these in calculus quite a bit. So we need, that's right, so we need f of a minus f of 0 over a minus 0. Let me make an f of 0 that's better than that. F of 0, there we go. Okay, so we have a squared minus 2 times a plus 3 minus 0 squared minus 2 times 0 plus 3 all over a, right? Because it's just 0. All right, so if we just simplify this out, what we get is a squared minus 2a plus 3 minus 3 all over a, right? Because the second part is just minus 3. So that really gives me a squared minus 2a over a, which is really a common factor of a can cancel out. So a minus 2 is the average rate of change for whatever interval from 0, whatever I want to put, basically. I can figure that out pretty easily. All right, pause the video, try the student problem. All right, student problem. We want to go from 2 to h, so starting at 2 and out to h, wherever that happens to be. So the average rate of change. Okay, so we have f of h minus f of 2 over h minus 2. Okay, so the first one, so negative 3h squared plus 1 minus, or put 2 in the second one, so negative 3 times 2 squared plus 1. That 3 didn't come out very good. We'll try that again. That's better. All right, so over h minus 2. Okay, so let's simplify here. So not much we can do with the first part, so it's negative 3h squared plus 1. So the second one would be minus, we'll put the brackets. All right, so if we do exponents, we get 4 times 3 is negative 12, plus 1 is negative 11. All over, what do we have, h minus 2? Okay, so we really have plus 11, so that's really what, 12, right? So negative 3h squared plus 12 over h minus 2. There we go. Right, that's the end of part 1.